boiler. So we're here looking at a hydronic boiler. This is not that old a boiler, 15 years. We see a lot older, 80 years even. You also see a lot newer. This is a Weil-McLain hydronic model, which means it doesn't send steam up via the steam rise of just the physics, but pressurized hot water to baseboard units. So I always try to look from outside. There we go. I always try to look from outside in. So first, we need to fire this thing. So this is where the oil comes in. If you see down here, number 2 oil. We've got our pressure gauges. This is our filter. This could also be gas. This could also be dual fired. This happens to be oil. If they were to replace this, we'd recommend a dual fired so that they could utilize gas for most of the year and oil when there's a high gas demand and therefore get a better price. This is number 2 oil. We're going to look at a tank in a minute. This fires the burner. This is the burner right here. It's literally just lighting the oil, sending into the fire chamber, and that's the fire eye right there where we can look and see what the color of the richness of the flame. This is our boiler in our tank to heat our water. It then sends up the heated water. Anytime you have a hydronic system, look at temperatures. Anytime you have a steam system, look at pressure. And then you can see what your recommended thresholds or set points should be. This is our waste, our flue. It's nice they have a temperature gauge here. It's a little higher than we'd like. We're going to recommend a tune-up. This is our waste gas, which goes out. So we're going to send our hot water up to our apartments. We'll have some inline pumps. So we'll send the water up. They'll provide the heat. They'll circle back. One other slightly interesting note about this is if you come over here, these 2 pipes right here are our tankless heaters. This is producing hot water. They're both rated at 12 gallons per minute. It's coming up as hot water, coming all the way over to here, and going into this thing, which is a mixing valve. And it does exactly what it says it's going to do. We send in really hot boiler water, which we can see our temperature, cold water, and then the mixing valve. There's several types. This is a newer type of mixing valve, electronic mixing valve. And then what it's produced, very hot, very cold, this here, domestic hot water. And we can see what our temperature gauge is where our water goes out. I can also check that in the apartments, but the 3 components of a mixing valve, hot in, cold in, domestic hot water out. So overall, I'm going to look at age, condition, rust, which is a big thing with boilers, leaks. I see a lot of water in the floor. I'm going to look for sources of that. The other thing is it's very hot in here. Water will dissipate pretty quickly. So you can see evidence of ponding. You see that white scaling, it's telling you water is there. So I'm going to look for that as well. Condition, puff back. When it fires and operates, we're going to get a little bit of a smell as it starts up. Particularly when you burn fossil fuels from coal, you're going to get a little bit of that smell, but it should dissipate pretty quickly. And we're not doing an energy audit, so I'm not doing a combustion test. But if I did a combustion test, by checking this flue, I could check a lot of things like temperature, CO2, oxygen content, etc. So overall, I'm going to look at condition, age, insulation, gauges, look at the records in New York City to see they're very well monitored with yearly check-ins and tune-ups and that sort of thing. So I'm going to do my search now, find my water sources, and then do my record search later. Thanks for watching. Okay.